Trig ratios of any angle. The primary trig ratios for an angle theta in standard position that has a point P, X, Y on its terminal arm are sine, cosine, tangent, blah, blah, blah. This is what it means when you have an angle in standard position. So something like that. There's a point on the terminal arm, so that would be P there. And the coordinates of it are X and Y. If you think about making that into a triangle by drawing a line to the x-axis, I'll just draw a line there. This length across the bottom is X and the height is Y. Because the point there is XY. So the X is here and the Y is here. It tells you that the sine of that angle, which is in here, the angle in standard position, is y over r. But we already know that sine is opposite over hypotenuse. And it also tells us here what r is. That's what I'm just saying. This tells you here what r is. Let me say it. That's what I'm in the middle of saying.
Yeah, Lance.
So what I was saying is it tells you here what r is. It's the square root of x squared plus y squared. Does this look familiar to any of you? That's the Pythagorean theorem. So, which means r is the hypotenuse right here. So like I was saying, the sine, this is a formula that is in your textbook. Sine theta is equal to y over r. But I don't really use that. I just remember that it's opposite over hypotenuse, because if you look at the diagram, that's what y and r represent. Cosine is x over r, that's adjacent over hypotenuse, and then tangent is y over x, that's opposite over adjacent. But you can use these formulas if you want, or you can just use what you already know about trigonometry. So here's the type of question that you may need to answer. The point -8, 15, the height is y, yeah. The point P, -8 and 15, lies in the terminal arm of an angle theta in standard position. Determine the exact values for the three primary trig ratios. So I'm going to draw a quick sketch of that. Where would that point -8 and 15 be? Quadrant 2, right. So somewhere up here, I didn't draw it very accurately. It's not easy to do on here. But your triangle is, you're going to draw always down to the x-axis. There's your right angle triangle. We're actually looking for this angle in here. And that should be connected right to the origin. It just doesn't always go exactly where I want when I'm drawing it on the iPad. So the side lengths of that triangle are -8 across the bottom and 15. The height. And then we need to figure out what r is. And that's just the Pythagorean theorem. R is equal to the square root of -8 squared plus 15 squared, which is the square root of 289. 289 happens to be a perfect square, so r is equal to 17. Sometimes you'll just have to leave it as the square root of something. If it's not a perfect square, just leave it rather than changing it to a decimal number, but that comes out to a whole number, so we'll use that for r. Then when we want to find sine of the angle, that's what it's asking us for, the three primary trig ratios. So it's asking us, what's sine of the angle? What is the cosine of the angle? And what is the tangent of the angle? Sine is y over r, so it is 15 over 17. Cosine is x over r, so it's -8 over 17. And tangent, y over x, so it's -15 over 8. I just put the negative out in the front rather than keeping it in the denominator, because we don't usually put a negative in the denominator. These are the answers that I get before simplifying. But all of these can be simplified. Negative 10 over 5 root 5. The negative 10 and the 5 have a common factor, right? Of 5. So that can simplify to negative 2 over root 5. But then that can actually simplify further as well. Negative 2 over root 5 needs to be rationalized. When you do that, you end up with an answer of negative 2 root 5 over 5. Negative 5 over 5 root 5 simplifies to negative 1 over root 5, but then do the same thing, rationalize it. So it becomes to negative root 5 over 5. And then the last one simplifies to 2. Yeah, 2 over 1, or just 2. Quadrantal angles. So you saw how that kind of works with a point and a triangle, and you could find the trig ratios. The problem here comes when you can't draw a triangle. And that happens when the angle is actually on one of the axes. You can't make it into a triangle. And so instead, this is the information that you have. When you have a point, say, well, at 0, the point is x and 0, which makes r equal to x. Because remember, r was x squared plus y squared, and the square root of that. Well, it's just x squared plus 0. And so it's just equal to, r is just equal to x. Up here, r is just equal to y. So on the x-axis, r is equal to x. On the y-axis, r is equal to y. You can still use the same things that you were using before, but you can't have a triangle because there's just no way to draw a triangle. It's just a straight line. So if you're given a point that's not on one of the axes, just do what you were doing before. But if you're given a point that is on the axis, you have to use this. So I want you to try to fill out the table below. I'm going to do a couple of them with you. If you remember, sine theta, it told us on the other sheet, was equal to y over r. So if I want to do sine of 0, which is what this first block is asking me to do, sine 0, I'm going to go to 0, and I'm going to do y over r. Y is equal to 0 divided by r. What's 0 divided by anything? 0. So it's actually just equal to 0. If I want to do sine of 90, I'll go up to where 90 is, and sine again is y over r, so it's y over y, which is equal to 1. I filled in my answers for cosine. Are those the answers that you got for cosine?
Yeah.
Okay, so how about tangent? Tangent of 0. 0. Because it's 0 divided by x, right? Which is just 0. What about 90? It's undefined, right. Why is it undefined? Because you're dividing by 0. And you can't divide by 0. So we say that it's undefined. And for 180? 0. And for 270? Undefined again.
If we have like a written explanation to this.
There is one other thing here that I want to show you that's kind of a shortcut.
Please.
Because, I don't know, you guys were saying that you like to do the least amount of work as possible.
Yes.
If you look at these x's and y's, you can actually just change them all to ones and it'll still work. So if you think of this as the point 1, 0, 0, 1, and then the r's are equal to 1, it might be kind of simpler. And because it's a ratio, it could be any number. And 1 is an easy number to work with. So often you'll see a similar diagram with, instead of the x's and the y's, you have just ones. And the answers come out the same, right? Because it's a ratio, y over y is equal to 1, no matter what y is equal to. So you may want to do that. Just change them into ones instead of x's and y's. And then it gets even simpler. If you look at this one, 0, for example, we said the sign of 0 is 0. Well, that's just the y value. And the cosine of 0 is 1. Does that work for all of them, where the x value is the cosine and the y value is the sine? So if we go to 90, does that work? Is this cosine sine? And same thing over here, cosine, sine. So if you have those points that are just the ones that are the quadrantal angles, the ones that are on the x or y axis, you can just think of the points as 1, 0, 0, 1, negative 1, 0, and 0, negative 1, and the values are cosine, sine. So you don't actually have to do the work if you can remember that. It kind of depends on whether you're good at remembering stuff or not. The other thing that you could remember, if you want to, is that tangent is actually equal to sine divided by cosine. And that's actually always true. The tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. These two triangles are called the special triangles. It is going to be worth your while to memorize those right now. For a couple of reasons. One, because there's going to be stuff on the exam and the test that deal with the special triangles, but also you're going to use them a lot in Math 30. And if you memorize them now, you'll still have them memorized. You don't need to memorize them again next year. The special triangles look exactly like this. One of them, this is the 30-60 special triangle. It's a right angle triangle with one angle of 30 degrees and one angle of 60 degrees. And the side lengths are 1, 2, and root 3. 2 is the hypotenuse. Any triangle that has the angles of 90, 30, and 60 will have the side lengths of 1, 2, and root 3, or some multiple of those. So we could multiply all those by 2 and get another triangle. We could multiply them all by 10 and get another triangle. But they'll always have that ratio of side lengths, 1 to 2 to root 3. And for one that's a 90-degree triangle with 45-degree angles, it's always going to be 1, 1, and root 2. And the ratio will always be the same if it's a triangle with two 45-degree angles. It'll always be 1 to 1 to root 2.
So memorizing will make it easier.
Memorizing is really probably necessary for some of the questions that you're going to have to answer, and it's definitely something you want to try to remember long term, like for Math 30. We're going to use these two special triangles to find exact values of special angles, of the trig ratios for special angles, basically. The other thing is this cast rule, which is what I call, there's lots of different names for it, but starting in quadrant 4 and going counterclockwise, it spells the word cast, C-A-S-T. This is not necessarily a concept that's usually in grade 11, but I'm going to give it to you guys because it helps with some of the stuff we're going to do. You're going to need it later anyway. What it means is if you're finding the trig ratios of an angle in standard position, if it's in the first quadrant, it's A, it means that they're all positive. So if you're finding the sine, cosine, or tangent of an angle in that quadrant, it's going to be a positive number. If you're finding it in the second, S stands for sine, so sine is going to be positive, which means the other two will be negative. And then tangent and cosine. I'm going to just leave it at that for now and then show you how it works on the next example. But that's something else to memorize. Determine the exact value for each of the following. Cosine of 135 degrees. So first thing we need to do is think about where would 135 degrees be in standard position? Which quadrant would it be in? In quadrant 2. And what would its reference angle be? 45. Reference angle is 45 degrees. That means this angle in here is 45 degrees. 135 is here. 45 is in there. So I put theta r for reference angle is 45. 45 degrees is one of the special angles because it's on one of the special triangles. So then I need to think about finding the cosine of 45, the cosine of the reference angle. So if I think about that special triangle that I had, it looked like this with 45 degrees in there and in there. From this special triangle, we can figure out what the cosine, because it's asking us for cosine, of 45 degrees is. What is the cosine of 45 degrees from that triangle? One over root 2? Yeah, cosine is adjacent over hypotenuse, so if we're looking at this 45, 1 over root 2, or you could look at either 45. But the cosine of 45 is 1 over root 2. Every angle has the same ratio for sine, cosine, and tangents as its reference angle, except that it could be positive or negative. But if the cosine of 45 is 1 over root 2, then the cosine of 135 is either 1 over root 2 or negative 1 over root 2. And we just need to then decide, is it going to be positive or negative? And that's where that other rule came in, that cast rule. It's going to be negative, you're right. Why is it negative, Lance?
Because it's quadrant 2, and quadrant 2 says sine.
Right. It's in quadrant 2. Quadrant 2 says S, sine is positive, so cosine has to be negative. Only the one that's listed there is positive, the other two are negative. So sine of 240 degrees. Where is 240 degrees? Which quadrant? In quadrant 3. What's its reference angle? The reference angle always has to measure to the x-axis. So it's this angle in here. Like from there to there. It's 60, right? Reference angle is 60. You can either do 270. Well, you probably want to do 240 minus 180. So subtract that part to get what's in there. And it's 60 degrees. So we need the other special triangle. This special triangle for this one looks like this. 1, 2, root 3 with 60 degrees down here and 30 degrees up there. You have that on your paper, but that's what it looks like. So we want to find the sine of the reference angle, so sine of 60 degrees. What's the sine of 60 degrees given this triangle? Root 3 over 2. So then what is the sine of 240 degrees? It's negative root 3 over 2 because it's in the quadrant 3 where only tangent is positive.